Welcome back to the engineering school. Today we will continue with the CAD beginner video series, and it is time for lesson 3, assemblies. Alright, let's go through what an assembly is. I have an assembly open right here, and you can see that it consists of several parts put together. First of all, let's go through the structure of an assembly. In the file manager, the window on the left side right here, we have a tab called Assembly Manager that we want to open in order to see the assembly structure. And if you don't see the file manager, remember that you can always toggle it on and off by clicking on the icon on the bottom right here. Okay, so let's go to the Assembly Manager tab, click on it. Here you can see a file called Reducer. This is a parent file for our assembly. You can see that it has a different icon compared to a single part right here. This means that it consists of different parts. And if we expand the assembly file, we can see the parts that make up the assembly. So let's go ahead and expand it by clicking on this arrow. Okay, so here we see the parts. And you can see that if I click on a part, it highlights on the assembly tree right here. And we call this an assembly tree because it branches out to different parts and sub-assemblies. This means that you can have assemblies within assemblies to organize your design. In this case, we don't have any sub-assemblies in our assembly, just to keep it simple for you guys. Okay, so what do we do to organize our parts in the assembly and keep them in a desired position to one another? Remember, when we created a sketch in lesson 1, we used something called constraints to control our geometry. In the same way, we use constraints in the assembly level. You see that we have a folder called constraints right here. And if we expand that folder, we can see all the constraints in this assembly. So let's go ahead and expand it. And you can see the constraints in this assembly. And basically we use all these constraints to control the parts within the assembly. Okay, so going back to the assembly tree, you can see that there is an F in front of one part, this part right here. And when clicking on the part, you see that it highlights in the assembly. So that's a good way to find a specific part you are searching for. F means that the part is fixed, you cannot move it. And it is fixed without the use of constraints. It is locked into place wherever you choose to fix it. So to free the part from this condition, we right click on it and click on the float command right here. This means that we can move the part again. So let's go ahead and drag it around. You see that we can move it. And you see that the other parts follow along because they are constrained to the base part right here. Now preferably you want to fix the part using constraints to be sure of its position in relation to the origin of the assembly. Remember, the part has one origin and the assembly has another one. So just to remind you, the origin is the point where all these planes intersect right in the middle. And when you design, you want to keep that in mind. So let's go ahead and add some constraints to the base part of our assembly, meaning the part that we will build up from. To make the part origin and the assembly origin, we want to use the planes of the part. So let's right click on the reducer base and click on unblank external datum. Okay, now you see that we can see the planes on the part right here. Okay, a little bit hard to see, but you can see them underneath here. So now to add constraints, so let's go to the assembly tab in the top menu and we click on it and click on the command common constraints. Here we want to use a constraint called coincident to mate the two planes together. Okay, so we want to mate the bottom plane of the assembly with the bottom plane of the part. And go ahead and confirm it. And then we want to mate this plane and this plane. So you see how it locks into place. And now it is only free to move in the X direction. So to lock it into place, we choose this plane and that plane. And go ahead and confirm. And now we can't move it. So let's go ahead and right click on the bottom part and choose blank external datum. That means hide. So this is how you lock the part into place without using the fix command. And now we can be sure that the origin of the part matches the one of the assembly. Okay, so there is not an F before this part anymore. You have probably also noticed that several parts have a minus sign in front of them. This means that they are underdefined, meaning that they have some sort of freedom in movement. For example, these parts. Now this can be intentional or unintentional, so it is always best to verify this. In our case, we want to verify a specific movement of the assembly, so we have this freedom of movement on purpose. Let's go ahead and blank the reducer cover to show the internal gears. And we right click on it and choose blank. Okay, so when we talk about blanking a part, we are talking about hiding it. That's just what it's called in ZW3D. Okay, so now you can see the internal gears, and you can see that if we move one gear, the other gear follows. And that's the freedom of movement that we have allowed in this assembly. Okay, so we achieve this by using more advanced mates that we will cover in future videos. Now, if we would fix this shaft, for example, we right click on it and choose the fix command right here. And you can see that everything locks into place. We don't have any minus signs in front of any part anymore. So we can go ahead and unblank or show this cover. And if we open the constraint status command, you can see that everything is fully defined. This is the constraint status command. And everything is green, that means fully defined. And you can see that the part that we have fixed is highlighted in this brown color. That means that it's anchored. So that's a good thing to keep in mind. Let's go ahead and close this. Let's say you want to edit a constraint of a specific part. To do that, you choose whatever part you want to edit the constraints on. For example, the small gear shaft. You right click on it and then choose the edit constraint command. And it will show you all the constraints for that part. Also, if you select a specific constraint, if I change the constraint here, it highlights the parts that this constraint applies to. Okay, let's go ahead and close this. So let's say you want to edit a part in an assembly. You can simply do it by double clicking on it. Now you see that the name is highlighted in blue. That means that you are working with this file. And you see that the other parts become transparent. Now this is good if you want to use the other parts for reference, but it can get messy sometimes, especially if you are dealing with several hundred parts. Now there are a few ways to isolate your part. One way is to uncheck the parts you don't want to use right here. Now this is not the best way, since it can take a long time when you're working in big assemblies with many parts. Let's just check these parts again. The other way is to go back to the assembly level by clicking on the exit button right here. Now remember that ZW3D works with levels to keep everything organized in one file. You can think of it like going up a level in a directory with different folders. So if we click on the exit button once again, we go back to the root directory of the file. And here you can see the parts, the assembly, the drawings, all in one file. So it's very handy. Okay, so going back to the assembly, we simply double click on it. Now the second way of isolating a part when working on it is to right click on it and choose the command show only. This automatically hides any other part. You can also hold Ctrl and click on several parts and then right click and choose show only if you want to work with a group of parts for reference. But let's just show one part in this case. So now when you have isolated the part, you can double click on it to modify it. And now you can go to the history manager and start adding or removing features. Alright, going back to the assembly level once again, we click on the exit button. And to show the other parts, we click on this little arrow right here. And it will show us a drop-down menu. And here we select unblank all, that means show all parts in the assembly. Okay, perfect. So the third way to isolate your part is simply by right-clicking on it and choosing open part. And this is the way I recommend you to do it if you want to work with a single part. Now it will be a little different when we go back one level. Okay, if we exit, you see that we go directly to the root directory since we open this part separately. So to go back to the assembly, once again, just double click on it. Alright, now let's create an assembly from scratch to show you how that's done as well. So I will just go ahead and close this part. And the first thing you do is to create a new ZW3D part/assembly. Okay, and let's name it assembly and confirm. Because ZW3D handles parts and assemblies in the same file, you don't have to worry about the specific file type. To build our assembly, we need to go to the Assembly tab right here and click on the Insert Part command. Here you can see the parent name being assembly, and to add a new name, let's just write in the name and confirm. Okay, and we go to the assembly manager. You see that we are working with this part right here. So to start adding geometry, we go to the shape command and let's just add something basic. That's good, confirm. And remember, if you want to add another part to the assembly, we need to go back one level again, clicking on the exit button. You see now the assembly name is highlighted in blue. That means that we are working in the assembly level and not the part level. So let's go ahead and go to the assembly tab once again and click on insert. And we can create a new part called ring. Okay, confirm. And we can add a shape to it as well. Okay, and we go back one level. Now if we try to move this part around, you can see both parts are free. So if we want to add constraints to the parts, we need to go to the assembly tab once again and click on common constraint. Now we choose two entities that we want to mate. Okay, we choose a concentric mate. We have the option to lock the rotation. Okay, let's go ahead and do that, confirm. You see that they can only move up and down in relation to each other now. Let's add another relation. Let's say this plane coincident with this plane. Okay, sounds good. Confirm and close. Alright, so now we have mated these two parts together. If we want to mate it to the assembly origin, we go ahead and repeat the process we did before. Unblank external datum, common constraints, coincident, and choose the planes. Now we can also create sub-assemblies in an assembly, and I will show you how to do that. So once again, go to the insert. We can call this sub-assembly, confirm. And to make this an assembly instead of a part, the only thing we need to do is to click on insert once again. And here we can reuse parts that we have created before. So I will just place this somewhere. Okay, confirm. and I'm still in the sub-assembly level. You see it's highlighted in blue. So I click on insert once again, and I can just place this right there. And over here you see that we can place the parts and add constraints how we want. But if we go back one level, this sub-assembly is treated as one. You see when I click on it, all the parts highlight, and when I drag it around, the parts stay in the position that they are in the sub-assembly. Now if I want to position the sub-assembly in a specific position, I can add mates to that sub-assembly. Okay, so that's good to keep in mind. Okay, so that's it regarding lesson 3 in the CAD beginner series. I hope that you have enjoyed today's lesson. Stay tuned for new videos and updates. Also, don't forget to subscribe and hit that like button. See you on the next video. Take care.